Thank you, my adoring fans. Please hold your applause. Good morning, everyone. Or it's still morning, isn't it? I've got about 8 minutes of morning, so good morning for 8 minutes. It's really cool to be down in Cape Town here with you guys today. I'm Dewald, I'm from ThoughtWorks. I have some social media icons down there. Go follow me on Twitter, I need more followers. And I came down here today to talk to you about a topic that I quite like. Now, I'll do my little introduction slide, that's me. And I really like fluffy hats and software development. And excuse me, presentation. There we go. And Sarah, hi sunshine. And I'm not actually a Java guy. So I'll be honest with you guys. I'm what they call a polyglot, like Cornel just introduced to us. So I spent a couple of years in C#, a couple of years in C++, some Ruby on the side, some Python here. Done about 2 or 3 years of Java, maybe a lot, maybe not. But the one thing that all of that experience has kind of done for me is show me that there's a lot of different ways to do things. The time I've spent in Java has been pretty interesting. But before we get into that, I'd like to take a trip back in time. Who remembers how to do this? Okay, everybody knows what's going on there? Hello world. First thing anybody learns in Java. It's very simple, right? It's pretty straightforward. There's a main class, there's a static method, we can call into that, and we get our text. And it's pretty easy to run too. We compile our Java file, and we execute it through the JVM. Profit, right? Who wants to give that a try in Java EE? I stole this off an example on GitHub, so if it doesn't work, caveat, not my fault. This is a web server that does the same thing. A little bit more complicated. Second question, who wants to try and run this? Because I'm pretty sure I can't Java C Java that won't work. So what's this talk actually about? It's pretty much exactly that. I've got some source code, I want to run it. What do I need to do? So source code. We write our business logic, all of our wonderful business rules, purchasing system, ordering system, client management system. Next step, gather our dependencies, build our artifact, configure our application, write some deployment descriptors, put it in an app server, configure the app server, put it on a host. Production! Fantastic! Yeah, okay, so that seems like a lot of stuff. And that's only like the tip of the iceberg, right? Because I mean, if you look at what app servers can actually do, I mean, you look at everything they can do, configuring connection pools and distributed caches and all of these wonderful things, there's a lot of stuff going on there. And all we really wanted to do was run some code in production. We wanted our client to log into our website and buy a car. Well, that would be nice. Why does it need to be so complicated though? What's with all these layers? Whatever happened to that Java Hello World application? I'll admit though, that's probably not a good user experience. But why does it need to be so complicated? Why do we need all of this stuff so we can get to production and we can go, cool, website's there now? And I'm sure a lot of you have a lot of answers regarding scalability and performance and all of these wonderful things. But all I want to get to is say that there's this thing in Java, and it's not quite unique to Java, but it's very paramount in Java, and it's called, I call it the application server monolith paradigm, which is a big mouthful for saying, let's take an app server, throw 50 apps on it, give it 128 gigs of RAM, and hopefully we can serve stuff in production. That's how we do Java dev a lot of times. And now there's a lot of you out here that probably don't do that. Some of you probably have smaller services, or probably 12 clustered instances and all kinds of fancy things like that. Maybe some of you have 200 application servers, and they're all distinct, so there's not just one. But every one of those is a big, complicated monster. Some of the things I've tried to do while I was doing DevOps stuff for a client was try and provision an application server. It was an Oracle one. So it was Oracle WebLogic. Has anyone ever tried to get Oracle WebLogic automatically installed on a host? So from downloading the zip file, to extracting it, to configuring it, to running those little domain generation scripts, it's a lot of work. It's a lot of work. And coming from all these other languages where I would go and say, okay, let's drop Ruby on the box and run our application and we're done, I kind of wonder why. Why do we do this to ourselves? I had a slide in here with a class cast exception on, but I think I threw it away. Core of the question, why do I need hundreds of megs of stuff and hundreds of lines of XML so I can run 5 megabytes of business logic? I've written, well, that's a lot of business logic actually. Maybe that's like a rules engine. But I need all this stuff so I can run like 5 megs of applications. And then there's all these other little things about it. Oops, I did take the slide out, damn it. So there was a slide in here with a class cast exception because I figured that would get a laugh from the audience because everyone here who's worked on an application server has at some point run their application and it's gone class cast exception or class not found exception. Because how many things are on that app server that you don't know? I had that with JotaTime once on WebLogic. I shipped JotaTime 2.3 or 4 or something. And it, of course, shipped JotaTime 1.7 because that's what they decided was a good idea. And yeah, the app didn't work. And there was no way for me to figure this out without deploying it to a WebLogic instance, which I couldn't get access to because licensing. So yeah, that was a lot of fun. So what can we actually do about all this stuff? I mean, I can stand here for 15, 20, 30 minutes and just tell you how I don't like application servers, and then get off the stage and we'd have accomplished nothing. So what can we actually do? Well, what if your deployment was this? Let's push a jar to a production box and start it. Hello world, right? Same kind of difference, it's just got the jar in it. What if your deployment was like that? Is this not a little bit simpler? No need to go and log onto a console and click install jar. Or if you're really, really good, write some Python scripts for IBM Websphere, because for some reason you scripted in Python. That's IBM for you. The key here is simplification. We basically wanted to take advantage of other technologies, because these big web application servers do one thing really well, and that's make you use everything on them. Use our deployment methodology, use our running methodology, use our monitoring, use our connection pools. Everything's on there. But what if we want to take advantage of other technologies? Why can't I do my deployment through Ansible or some scripty stuff? Why can't I do it through Bash? And the quintessential question, has anyone ever tried to run a web application server in Docker? Yes. You got JBoss to run a Docker. Yeah. That man, give that man a bells. It's got so many dependencies that you don't know of. So take advantage of other technologies instead of having this one tool to rule them all. Oh crap, who's sending me emails at this time of day? So here, I'm basically trying to say that there are lots of things out there that manage things that we've been using for decades. Supervisor, has anyone made use of Supervisor before on Unix? No, I'm obviously talking to a Java conference. There's one guy back there, fantastic. Is a thing for monitoring Unix processes and treating them as Unix processes. For those of you who have done some C++ development on Unix, you'll know that PID files are a norm. Generate a PID file, know how to kill a process, know how to start a process. Signals are a norm. Has anyone ever used this with Java? Oh, Pavel? Well, it's a couple of people, cool, right, yeah. We don't, right? Well, a lot of times we don't, except for a couple of people. We treat Java as its own little sort of ecosystem. Once that app server goes on the box, that is the host. The host around it is just there to support it. Like someone at Oracle should just invent Java Docker, because they've pretty much done that. So yeah, and if we want to take advantage of all this stuff, I introduced to you the art of dropping your application server, or Java SE for the enterprise. Don't replace my S with an E, it's a different thing. And by this I'm not saying let's drop all the Java EE standards. Drop all the Java EE standards, please. I'm saying that we don't need these huge humongous things to do simple business things with. So here's a tool. Who's heard of Spring Boot? A couple of you, yeah? I like this little twig. I like the fact that I bolded production grade in there, because I knew there'd be a bunch of devs here who would ask me, but how do we do it in production? Well, Spring says you can do it in production, and they're pretty good. It's an opinionated framework. So the idea is that you pull this, you either start with one of their Maven POMs, or you pull in the dependencies, and you can build it into a jar, and you can run it. You don't need to deploy it to an application server. You don't need to configure deployment descriptors, thankfully. And you don't have to worry about class cast exceptions because it packages all the dependencies inside of one jar. And all of that's in one memory space, one JVM instance by itself. And that's your application. It just runs. It's just one tool. There's another tool called Drop Wizard, which apparently does not want to appear on my presentation for now. And it's gone. OK, good. There was picture an icon of a wizard's hat with a staff. Drop Wizard is another framework, and that's actually skips Spring and Java EE altogether and just says, cool, we'll give you a framework that uses Jersey, Jackson, and all the base libraries to produce applications. We don't need all this EE stuff. The thing I love about Drop Wizard is that you can get a production-grade REST service, and it'll clock in at around 4 megs or so, or 5 megs, if you exclude enough stuff. Still a lot better than the 1.5 gig install I did of Websphere the other day. Does anyone know why Websphere is 1.5 gigs? Okay. Give that man a bells. Like it boggles my mind. You know, hey, I need to host this REST service. Let me just install 1.5 gigs worth of stuff. I didn't want to install Windows to host it, but whatever. So those are just some frameworks. I think it's broken now. Yeah, it's given up on me. Possibly, let's see. This is why you shouldn't host presentations on GitHub. And it's dead. Oh. Back to the code it is. Anyways, so I'll just speak from the HTML instead, because that works, right? Ah, slides. Anyone used Atom before? I'll give Atom a free punt. This is the best text editor ever made. It's all JavaScript. It's amazing. It's got the word Java in it, so it totally counts. Right. I don't know, my steps have decided to not load up anymore. I'm assuming I did some weird stuff. Oh, there we go. We've got a dead div lying around. Aha, you little thing. Let's try that again. Do that with Keynote. All right, look, the hat, it appeared. So Drop Wizard is basically a set of libraries, as I said earlier, blah, 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 but that's the pretty logo. Right, so key thing, a lot of people, when they hear the words Drop Wizard, when they hear the words Spring Boot, they think immediately microservices, right? It's going to be a bunch of small running jars. It doesn't have to be. It can. I really like that idea. I like the idea of having 15 jars running instead of one really big app inside of a web container, but it can be a monolith. You can write an entire monolithic Java jar app. Doesn't have to be a microservice. You package everything you need inside of it. So remember how I talked earlier about class cast exceptions and class not found exceptions? Think of the past, man. All the code's there. And it's all inside of one JVM instance, so stop worrying about filtering class loaders and all that other nonsense. And lastly, there's no licensing fees. This is all open source. Yay for commercialism. That one should have drawn a bigger laugh. Apparently you guys are definitely not the guys who pay the bills. If you present this line to any CIOs or CTOs, they just start clapping. Like, no licensing fees. Right, how do we manage in production? I mentioned earlier that we have this idea that our web servers, our application servers, are the one tool to kill them all, right? We've got lists of running applications. We can plug into JMS, and we can pull stats out. We can do all of these cool things, trademark, if you can get them on the app servers and they start up. How do we do this with runnable jars? Well, I mentioned supervisor earlier, basically running your jars as processes on Unix and monitoring them like that. Another option that I've explored recently is to use Docker to run a simple jar inside of a JVM and manage that through something like Shipyard. There's a ton of tools out there that do this so well. And apparently I didn't have the time to download their logos. Now your Java app is the same as everything else. Think about that. I mentioned earlier, your Java app lived in its own little ecosystem, its little box, its app server world, surrounded by beans and wonderful things. Now it's just the process running on the box. It's like every other thing you run. I mean, how many of you have ever run a Python app in a web application server before? Yeah, there's 1, 2, 3. Apparently, I'm not up to date on my Python. I've never done that. Was it WSGI or something like that?
I can't remember, but it's like one line.
Jeez, that's so much better. Maybe this talk should be about fixing application servers instead of dropping them. switching everybody to TomCat. But you don't get that, right? Your Python app is usually an app. Your Ruby app is usually an app. Your C++ app, I don't know how to run that in a web container. Link into it, J and I. But it basically becomes just another process on your box. It's not special. I had a line in here somewhere, and I think I got rid of it again, about how I wanted to ask the entire audience, how many of you know what your command line is to start your JVM? So you've got 50 production apps inside of Websphere or Oracle WebLogic or JBoss, or how many of you know what that command line is? Or is it less than 250 characters? Probably is, because Windows would crash if it wasn't. But you don't. You just trust the web server that it's setting up some sane defaults. I can tell you that one thing everybody here knows is how much permgen space there's set up. Java 8, woohoo. But this requires you to write your Java command, right? So I'll know exactly how much memory I've allocated. I'll know exactly what options I've set. And how hard is it to debug this? Stop the app, -d, done. I know, works for me. So last thing, I've gone through this rather quick because my presentation broke. But I can take like questions for 20 minutes, it'd be fantastic. So the last question I always get asked is always this last thing. Oh, this sounds great if we were a startup. Or it sounds great for my GitHub open source project. I'm an enterprise. Can I actually do this? Yeah, why not? Take a new project, try it out. Or shard off a piece of your existing functionality. I'll tell you one thing you will find out if you do that. You'll find out what dependencies your application actually has. Because that's another thing we don't know, is how much of that stuff on the web server do we actually need before our app will start up? I went through an exercise at a Microsoft assessment once, where we were trying to figure out all the DLLs on the system that they needed. And everybody always says Microsoft, DLL hell, right? Tons of C++ stuff in the system.td directory, and you have versioning issues and all these things. It was easier than figuring out what binaries, what was on the web container, and how to work with it. Because IBM went and repackaged a bunch of it into their own jar. Yeah. So thanks, IBM. You're wonderful. So yes, you can do this. And we have done this. And it's difficult to change minds. You always run into people who say, we need our application servers. I find the best strategy is to get them to set one up on their local machine. So take their laptop, throw it out a window, and then tell them to set up their dev environment again. It'll take them 2 days, and they'll decide to drop application servers after that. A very good exercise. Some of the other advantages of this, if you want to sell it to your company, is ask them how long it would take them if a meteor struck their data center. Ask them how long it would take them to reset up those once-in-a-lifetime golden egg application servers. To remember to tick that box on page 4 of advanced settings. The one on the left. Because the one on the right crashes the app server. It's like all these crazy things. One of my favorite quotes from a guy that I was talking to about this exact thing. He was in a situation where they were deploying to a bunch of app servers, 12 of them in production, Oracle WebLogic. And 11 of the servers started up, and the 12th one didn't. And so I asked the guy, what's wrong with the 12th server? And he says, class loader entropy. Java, we have a problem. But I don't think it was class loader entropy. If you ask me, it was that one little box that wasn't ticked on page 4 of the advanced settings. Most certainly. But yeah. I apologize, guys. I had planned to do this in 45 minutes. I seem to have done it in about 25, which is magnificent. So how about I stop now, before all of you get truly bored, and take some questions, and then we can all go on lunch. Oh, one more. Gee. Sorry, I don't get to bore you into lunch. Anyways, yep. We built production applications for some clients in Uganda. It's mostly REST-based APIs. So, yeah, I don't know how.
Yep. What sort of application?
Good question. I'm trying to consider my NDAs at this point. It's
vague. Very vague.
Very, very vague. It has clients. There are people who use it. No, I'm kidding. It's a REST API for a front-end JavaScript website. So there's an Angular nice JavaScript application, and then there's a REST API behind it, a bunch of them. And it's actually a microservice thing, so we've got about 4 or 5 of those services. And they are all fairly independent, stateless things with their own database. It's a really nice architecture. The only thing that could make it better was Docker. So yeah, and that's a full production-grade system that we're running in production. Tomek?
So you've done some microservice architectures.
Mm-hmm.
Do you have services that talk between themselves? And how do they communicate? What kind of protocol do you use? And I assume you've got some sort of central repository or somewhere, registry service where the services can register to, so that you don't have like hard-coded parts where the endpoints are. So what technology do you use to accomplish that?
Wow, I wish I had one of those registries. That sounds awesome. So the services do intercommunicate, they cross-communicate. They talk mostly HTTP in that specific project example. I've done other ones with some lower level stuff before, but mostly everything is HTTP. And as for service discovery, they don't do service discovery. That particular project, they just knew where one another were on the VMs. Not a particularly good setup. My recommendation would be, if you want to look into something like that, I've been messing a lot with Docker. Docker does a really good job of linking your containers together, so your container only has to know a reference to another container. I'm not going to turn this into a Docker talk, but we can always chat afterwards. I love Docker. I talk about it all day. But yeah, service discovery, I haven't played with it that much. Really cool.
Yeah.
The one lonely microphone. That's okay. You can give it to me, I'll run around and give it to people. It's Cape Town, man.
So how do you handle monitoring?
How do I handle monitoring?
Yeah, so how do you monitor your production deployment? How do you make sure your connection tools are right, and all the kind of things that app service give you?
Good question. So the first thing is Dropwizard and Boot, for example, they both ship with fairly strong metrics support. So the idea is that each service will expose metrics about itself. They're also still JVM instances. So if you want to run agents against those JVM instances and monitor them with Dynatrace, free plug for Dynatrace, you can still do that. They're still normal JVM instances. I've used health endpoints before, so using the metrics, CodeHell's metrics library to set up certain checks, are these DB calls timing out or taking long, that kind of thing. One of the great advantages of doing that is that it becomes very easy, because you're no longer fronting all of your applications in one HTTP server, you're probably going to have some form of load balancing in front of it, because you'll have multiple instances of them. And it's difficult for the load balancer to know whether it should send to a service. Maybe one of the services has gone bad. So that health endpoint, that same endpoint that we can use to monitor the service, we can make our load balancer aware of the fact that it's there. And we can make our load balancer know, don't round robin to this one service, it's currently in a bad state. So I've used that before to do it. And as I said, you can attach agents to the JVM if you want to. It's definitely, so the one thing I will say is there's a lot more work involved here in orchestrating things on the deployment level, right? So we've taken complexity out of this massive stack of stuff, but it has to go somewhere. We can't just get rid of it, unfortunately. And so typically things like deployment, as you were asking earlier, deployment has to be orchestrated with a different tool. And that thing may become slightly more complex because now you have 15 jars to deploy instead of one big app server. But there are really good tools to do that with. Some of those wonderful state management config things like Puppet and Chef and Ansible, that was a terrible name for them. They're very, very good at making sure that the right version of your app is on the right server with the right stuff running. It's a lot better at it than the web server is actually at it, your application server. Because usually, I mean, depending on how sophisticated your operations are, a lot of people just log onto a console and install a jar or a war. And that gives you a lot better kind of know what's going on in your servers. So I'd say there's a bunch of tools that allow you to do it. On the Java side, you can do metrics endpoints and agents. On the process side, monitoring processes, there are tools for that as well that I will just name is now forgotten. Think of one now. Actuator. Oh, Spring Boot Actuator. That's a good one, Cornel. Thanks. Spring Boot Actuator is a little extra thing you can add into your Spring Boot project. So if you start with a base Spring Boot project, you can add Actuator. Actuator gives you a bunch of free production stuff that you want. Typically, your health endpoint actually comes from Actuator. You'd also have endpoints to see things like what's my JVM's memory usage. There's some to dump out even more information about what's going on in the thread stack. You can do all of these kinds of, get all this kinds of information out of it. It's a really cool tool, and it's all, Trace is there. It's all there. They've put it down for you. And it's over HTTP, so I can do it in the browser directly against the service if I wanted to, which is kind of cool, if you ask me. Cool.
What's the process from taking a Java EE and transferring it to something which is containerless?
Rachel answered this one for me earlier. It starts with deleting Websphere. No, I'm kidding. So it can be quite an involved process. It depends on how big the EE app is itself, how much it relies on container functionality being there, if it has any strict dependencies on a specific container type. My suggestion would be don't try and port the entire thing at once. Take a shard of functionality out of it that can be built standalone, maybe in a microservice way, as a start and build it out, or take a new feature and do that. And handle communication on a routing level in HTTP, if it's HTTP. Because that process of turning an EE app into a containerless app, if it's a big enough application, takes weeks. Because you have to identify all those dependencies and you have to go through all that stuff. So I'd say start with something, a small little bit of it, and see whether it works for you or not. Yeah, very true. All of that is in Spring. Well, it's nothing that ensures that the world doesn't end. So yay for that. Most users, I'm going to have to think of the numbers now. I think we had 24,000 concurrent users at one point on one of the platforms. That was with one of our projects, Uganda, I think. And then as for mission criticality, that was a replacement for their existing website. So it's basically their web presence. Probably the most difficult things would be the typical Java EE sharing bean instances and memory thing between multiple applications. But then again, that whole idea, so I think that's very difficult. Is if you think about traditional Java EE development, it's difficult to do it without an app container because you can't do it. So there are some aspects of it that become quite difficult. I haven't found a feature that Spring doesn't have a library for. That's very cool. Cornel was saying earlier, I should mention, Spring JMS does all of that integration, and there's a whole bunch of other projects that handle very many of the features that you get on an app container. I haven't run into anything that I wouldn't be able to solve just using a kind of microservice HTTP-based approach and breaking things apart. Yeah, don't know if that answers your question fully. Maybe I will one day. Maybe I'll find out. It's probably going to be SSL termination. It's always SSL termination. I was watching Josh the other day set up SSL on TomCat. Has anybody done that? Yeah. Yeah,